Okay, today we're starting chapter 8, and the first section is about pairs of angles. So it says, when two lines intersect, they form several special pairs of angles. So the first kind we're going to talk about are adjacent angles. Adjacent angles are next door neighbors. They have a common vertex, a common side, but no common interior points. So 1 and 2 would be adjacent, right? They're next door neighbors. They share a fence. They have this one common vertex. These two, 1 and 2, are adjacent. So look at the next slide. And there's a couple things that are not adjacent. The first is like here, angle 3 and 4. They have this common vertex, but they don't have a side in common, right? Angle 3 is here, angle 4 is here. There's no side that they share. If you look at this middle one, angle 3 and angle 4, they have the common side, but do they have a common vertex? No. Here's the vertex of 4, here's the vertex of 3, not a common vertex. This one's a little hard to see because it's not in color. But really quick, angle 3 is talking about this. This angle right here. And angle 4 is talking about this part right here. So this whole angle is 4, and then this angle is 3. Okay, so even though they have this common side, right, and they have a common vertex, they have interior points in common. That means if I put a point right here, that's inside angle 3 and inside angle 4, so that's not allowed. So adjacent angles, one angle can't be essentially inside the other one, right? Angle 3 is inside of angle 4. Then the other kind of angle, my paper is being janky, is, sorry, I've got cords everywhere here, are vertical angles. That's the other kind of special pair that we have to talk about. Vertical angles are formed by intersecting lines, and they are opposite each other. Vertical angles have the same measure, so they're always congruent. So angle 1 and angle 3 would be vertical. Okay, they're facing each other. When these two lines intersect, they are exactly opposite. And then angle 2 and angle 4. So if I were to tell you that this angle was 80 degrees, then angle 3 would also have to be 80. They're like mirror images of each other. Okay, so let's look at your next slide. It says identify a pair of adjacent angles. So you can do this. There's tons of different neighbor angles. What I like to do when I'm naming an angle is I kind of like to go in and put like a dot inside the angle. So I'm like, okay, or a little, like I'm talking about this angle right here and this angle right here. Okay, these two angles, they have a common vertex and side. So they're next door neighbors, they're adjacent. So this green angle right here would be angle DBY. And the orange angle would be angle YBT. You're essentially telling someone how to draw it. Like you would go from Y to B to T. Oh, that's this part right there. Okay, there's tons of different pairs. You could have named TBJ and JBD. Any two angles that are next door neighbors, they share a vertex and a side, are adjacent. So vertical angles. I'm going to use my same first angle, angle DBY. So now what angle is directly across from it? Angle JBT. So we want to make sure that if it says a pair, right, a pair is 2. Okay, so make sure if it asks you for a pair of angles, you're naming both. So then down here, it says if angle DBY is 80 degrees, so this is DBY, and that's 80 degrees, it says find the measure of JBT. So JBT is this angle right here. So what would it have to be? 80 degrees, because if they're vertical angles, they're mirror images, they're directly across, and they're congruent. So now it says if angle DBY is 80 degrees, Find the measure of JBD. Okay, so let's see. If I put these two together, what do I get? What is that? That is a half circle, right? Do you know how many degrees are in a half circle? 180, right? This line is flat. If you put two angles together and they make a flat line, then that's a 180 degree angle. It's called a straight angle. So that would mean that JBD had to be 100, because when I put these two together, they made 180 degrees. So if you look at your next slide, we can talk about what that is called. That is called supplementary. If the sum of two angles is 180 degrees, the angles are supplementary. So if I have a 105 degree angle, this would have to be 75 degrees, because when I put them together, they make a straight angle, which is 180. They're supplementary. If you put two angles together and their sum is 90, then they're what we call complementary. So here's that same 75 degree angle. When I put it with 15, those two are complementary because they made a 90 degree angle. So it says, suppose the measure of angle BCD is 121 degrees. Find the measure of its supplement. Okay, you are free to use a calculator. So supplement means that it should add up to 180. So we're going to do 180 minus 121. And I get 59 degrees. So if angle BCD is 121, its supplement would have to be 59, because when you put them together, we want them to be 180. So suppose the measure of angle AHY is 43 degrees. Find the measure of its complement. So complementary degrees add up to 90. So 90 minus 43, you can type it into your calculator, is 40, oops, I just wrote 45 and I was about to say 47 degrees, because when you put 43 and 47 together, they make 90. Okay, on to this next part. It says you're given an angle measure and asked to find the complement and the supplement. So remember, complementary add to 90 degrees. So let's do those first. So if it's a 35 degree angle and I'm trying to make it add to 90, 90 minus 35 is 55 degrees. On this next one, 90 minus 71 would be 19 degrees. On number 3, 90 minus 48.5 is 41.5 degrees. On number 4, 90 minus 62.3 means the supplement has to be, complement, 27.7 degrees. Okay, so let's talk about what the supplement is. So supplement is when they're going to add to 180. So 180 minus 35. I'm going to kind of cover that part up. So 180 minus 35 means the supplement of that first angle would have to be 145 degrees. 180 minus 71 is 109 degrees. Number 3, 180 minus 48.5, 131.5 degrees. And 180 minus 62.3, 117.7 degrees. So we found the complement of 35 and the supplement of 35. The complement of 71 and the supplement of 71. The complement to 48.5 and the supplement. Okay, the next thing that we're going to do is we are going to essentially fill in almost like a little puzzle. So it says in the diagram below, the measure of angle 5 is 58 degrees. When you have that little M before the angle sign, it means the measure of. So the measure of angle 5 is 58 degrees. So it says find the measure of angle 1, angle 2, angle 3, and angle 4. So I'm going to put little spots here for each of them, and then let's kind of go through and see if we can figure out what each angle is going to be. So if angle 5 is 58, it's directly across, it's the mirror image of angle 2. So what would angle 2 have to be? 58 degrees. They're vertical. So angle 2 would have to be 58 degrees. So now let's figure out, well, what other kind of pair can I look at? Well, what I can look at is this little box here in the corner, right, is indicating that this is a 90-degree angle. So 58 plus what would make that 90? 32 degrees. So I know angle 1 has to be 32 because 32 and 58 make 90. Well, if angle 1 is 32, angle 3 is directly across. They're vertical, so angle 3 would have to be 32 degrees. So the last one I'm left with is angle 4. Well, what could angle 4 be? Well, if I put this angle together with angle 4, it made a straight line. This one is 90, so angle 4 has to be a right angle because they are supplementary. When I put together this angle right here with angle 4, it made a straight line. Okay, now we're going to combine some algebra skills, things we've done before, okay, with some of the pairs of angle concepts that we learned today. So before you freak out that there's x's, what do I know about these two angles? About this angle and this angle? Are they complementary, supplementary? Are they vertical? What are they? They are vertical angles, which means that they are the same. So that means that whatever x plus 200 degrees is, it has to be the same as 3x, correct? Whatever x, so if this is 500, right, this angle would have to be 500. That doesn't make sense because it's a, that's way too big. But, hold on, let me look at this. No, I didn't mess up. So whatever this one is, this has to be the same. So that's why I set x plus 200 equal to 3x. So now I'm going to solve it for x. I have x's on both sides of my equation. I don't like that, so I'm going to take one away from both sides. So now I'm left with 200 equals 2x. So then if I divide both sides by 2, what would I get? 100 equals x. Okay, and I'm just going to go ahead and tell you that I should have made this 20, not 200, because there's no way that this could be a 300-degree angle. But for intents and purposes of solving the equation, okay, we solved it for x. So let's look down here at number 9. Okay, so on this one, I'm like, okay, what do I know? What do I know? Well, I know that this angle is 90 degrees. It tells me that with that little box. I know that if I put all three angles together, that made 180 degrees. So if this is 90, what's left for these two? 90. When I add 2x plus 10 to 3x minus 25, I should get 90 degrees. Because this is 90, so there's 90 degrees left for these two. So combine my like terms. 2x and 3x is 5x. 10 minus 25 is minus 15 equals 90. If you all thought that our equation skills were going away, you thought wrong. Okay, so now we're going to add 15 to both sides. So I get 5x is 105. I'm going to divide everything by 5, and I would get x equals 21. Okay, and all it's asking you to do is solve for x. But if you think about it, 21 times 2 is 42, plus 10 is 52. And then here, 21 times 3 is 63. 63 minus 25 is 38. Let me double check that. 63 minus 25, yep, is 38. And look, if I added, I have a 52-degree angle, a 90, and a 38. That's 180 degrees.